This is a different kind of problem which they may ask you to prove using induction. It isn't to do with the sum, but it is to do with the sequence. Proof by induction is our main tool to prove results when it's about sequences and sums. Okay. Now the sequence here is what we call an inductive sequence. Because each term, the next term, is defined by the one previous to it. Okay? And we have to have the first term. We have to have the first term where it starts off. So u1 is equal to 4. Then 4 lots of u1, which is 4 lots of 2, is 8. Minus 3 gives us u2. So u2 is a very popular Irish rock band, but in this case it's also 5. Okay. U3, what's that going to be? Any ideas? Laura, you had it, didn't you?
17.
Yeah. 4 lots of 5 minus 3 is 17. What's the matter? Oh, sorry, U1 is 2, yeah. Carried away thinking about Bono and the Edge. U4, and the other two guys, you know what it is. U4, Regan? 4 lots of 17. 68 minus 3, 65, good. And we're not going to go much further. U5 is the last one. Go on, Sam. Give you that one to.
20 plus 257.
Yep, 257. 4 lots of 65 is 260. Minus 3 is 257. This sequence appears to be getting big very quickly. Okay. The next one is going to be, in the thousands. The one after that will be, close to 5,000, from the 4,000, 5,000 mark. Stephanie, I heard about your flat tire.
Yeah.
Any luck?
No.
Okay. Okay. What we're going to try and do is to prove the general term. Here we've got an inductive sequence, an inductive definition. Here, what we've got here to prove is what we call a deductive definition. Now, it depends. Sometimes we prefer to have the inductive definition, sometimes we prefer the deductive definition. Here, this formula here is going to give us a term based on what number term it is. Okay, so we can U100s, instead of having to work out all of the ones up to 99 and then work out 100 using the inductive one, we can just say is 4 to the 99 minus 1, because n is 100. Now that probably won't be able to calculate that in your calculator because that is massive. Okay. The point is, how do we know that this is true? How do we know that this formula is true? We have to prove this formula from our inductive sequence using proof by induction. Okay? And that's what we're going to do today. So, step 1. What is our first step for any proof by induction? And this will get us marks, and it's the easiest part. Jack, base case. We need to prove the base case. Prove base case. And usually this is when n is equal to 1. Sometimes it might not be, but most of the time n will be 1 here. Okay? Now, using that formula, u1 is equal to 4 to the 1 minus 1 plus 1. 4 to the 1 minus 1 is 4 to the 0, which is 1. 1 plus 1 is equal to 2. And we know from the question that u1 is equal to 2. So base case has been proved. So base case is proved. Okay? Now, 2. What are we going to do? What's the second part, Stephen? Yeah, so what's the inductive step? Go on. Yeah, we assume it's true for n is equal to k. We assume that it's true. Okay? So we have u to the k plus 1. No, sorry. U to the k is equal to, in this case, 4 to the k minus 1 plus 1. We're saying that this statement here is true. Now we need to prove, from here, we need to prove that the k plus 1 statement is true. And so our target is uk plus 1. So here I'm just replacing k by k plus 1 is equal to 4 to the k plus 1. Okay, this is our target. Once we've gone from there, once we work this out, we're fine. So any ideas? We've got UK, how can we get from UK, how can we get to UK plus 1? Stephen?
K plus 1 first.
No, that's what we do for the other one, because that's a sum. This isn't a sum, this is just a definition. How do we get, what is, the bit we know, the only bits we know is that this is true, and what else is true? What is the expression for UK plus 1 from the question? We've all got it written down somewhere, right at the top. Sam?
UN plus 1 equals 4 UN take 3.
Or UK take 3, yeah? So this bit has come from the definition. This has come from the definition at the beginning. We know that UK plus 1 is equal to 4 UK minus 3. Now we know that UK is true, because that's what we've assumed. We've assumed UK is true. So substituting UK 4k minus 1 plus 1 into there, we get UK plus 1 is equal to 4 lots of 4 to the k minus 1 plus 1 minus 3. I think some of you can see where this is coming. I hope we can multiply these brackets out. What's 4 times 4 to the k minus 1 simplified to? 4k, yes, because this is like 4 to the 1. Add in the powers. 1 plus k minus 1 just becomes k. That's a weird way of writing 4. 4 times 1 is plus 4 minus 3. Regan, what does this mean?
UK plus 1 does equal 4k plus 1.
UK plus 1 does indeed equal to 4k plus 1. Yes?
When you multiply 4 to the 1 by 4 to k minus 1, it doesn't come 16 to the k.
Okay, because we add powers.
Yeah.
1 plus k minus 1 is 4 to the k.
I get like when you multiply with brackets, the powers multiply instead of add. But why don't the 4 like? Because it's 4 times 4, isn't it?
No, it's 4 times 4 to the k minus 1.
So 4 times 4 is 4 squared.
4 times 4 is 4 squared.
Yeah.
4 times 4 to the 4 is 4 to the 5. So
Add the powers.
we add the powers.
You put the brackets.
Sorry, I'm a bit confused. I think
Yeah, no, it's like if I was going to do 6 times open brackets, or 6 to the 6 squared times open brackets, 4 cubed, it would be 24.
no, it wouldn't. No, these are different
Going on in
bases.
my head.
Yeah, these are different. If we're doing this, for example, 6 squared times 4 cubed, we can't really do anything with that. That just
Yeah.
because they're different. The bases are different.
Yeah.
Here they're the same. Okay, I think we've had a bit of a moment there,
I
didn't
get
we?
it now. Sorry, I don't know where I'm getting that.
It's a shame that, Steve, because we are recording.
Oh God.
It's okay. It's okay. No, it's fine. It's fine. Because this is what it requires. Steve, it's good to ask questions.
What lies to the fool?
No, it's good to ask questions. It's good to ask questions, and it's important for you to understand. Link Connect, the amount of times I've made fools out of myself on these videos. was talking about you too earlier. I mean, what's all that about? So we've got our target, therefore, proved, done. Okay. Now what this means is, remember, that if we've got a stack of dominoes, and each domino represents an n, we've proved that n equals 1 works. That was the base case. Okay. We've then proved that we said that if n equals k is definitely true. We've assumed that. You know, it's a bit of a big step. Don't assume. Because usually we've proved anyway that if k is true, then that knocks down the next one. Okay? That's what we've proved. That is the whole point of induction. Now, because we've proved the base case, this tells us then that if n is 1 is true, then definitely n is 2 is true. And that means that n is 3 is true because n is 2 is true. And so on and so forth, and the whole dominoes fall down. Samuel,
Surely
love.
once you've proved n equals k, you know that it's true.
Yeah, but we haven't proved n equals k. That is the inductive step. We've assumed it's true for n equals k. We've assumed that that statement there is correct. But if we assume that statement is correct and then prove that for the next one, uk plus 1, it's also correct, that is the induction. That is induction. That is proved by induction. Does that make sense?
Yeah.
We're not proving the case, we're assuming that. We're proving the k plus 1th case based on the truth of that statement there. Yeah? So, that's why the base case is incredibly important, because we need one case to work, because if one case will work, then they'll all work after that. That's why it's an incredibly powerful method of proof. Okay? Now, this kind of question could come up in your exam. It's a bit of a 50-50, whether you get a question involving sums or a question involving sequences. So I think the sequences ones are nicer. There's less letters. We haven't got R's. And we haven't got R's involved, which I think made things a bit confusing last lesson. But this is it. You don't have to draw little dominoes going as well for your solution. Okay? Anyone want to say anything before I stop recording?
Yeah, I realised what I got confused with. What I can call whatever many times like 2x cubed by y squared by 4x. Yeah,